I'm talking today about using 3D dynamic scene graphs as a planning aid for manipulation. Dynamic scene graphs are a hierarchical graphical model that were recently proposed by Russell et al. As an environment representation for robotics applications. A dynamic scene graph consists of 5 layers. Layer 1 is a 3D semantic mesh. Layer 2 contains nodes that represent either objects, which are depicted here, or agents, which aren't. Layer 3 contains places, nodes that represent areas of free space and form a topological map of the environment, and structure, nodes that represent structural elements like walls, shelves, and other large objects, and elements that are not easily manipulable. The 4th layer contains rooms and hallways and is basically a floor plan. The final layer contains buildings and typically consists of a single node which can be considered the root of the scene graph. Dynamic scene graphs can be estimated directly from visual inertial data. Here, I'm showing the estimated DSG that is being constructed as an agent moves through a simulated office environment. The robot constructing the environment is shown in purple with the label 2A. Dynamic scene graphs show promise for navigation-style tasks in larger scale environments, especially when the task requires semantic context. But the goal for 3D dynamic scene graphs is to be a flexible, multi-purpose representation with many robotic applications in mind. So the natural question is, can we use dynamic scene graphs as a planning aid for manipulation tasks? I chose to use a mug-on-shelf style task as a motivating example. The robot is asked to move some objects from where they are to a structural element in the scene. One goal for the project is to add the ability to the dynamic scene graph to be able to model relationships between objects and structure, an important feature for both specifying a goal configuration of the scene and assessing progress towards the goal. The second goal for the project is to enable grasping and manipulating objects using their attributes in the scene graph. I set up a simulation environment in Drake with 2 structural elements, tables, and several objects. The detected relationships are handcrafted and proximity-based. The edges between the object nodes, the cyan and pink spheres, represent objects that are near to each other. Edges between structural elements, the magenta boxes, and objects represent an on top of relationship. The arm has a gripper mounted camera, and I use an optimization based on inverse kinematic solver with case and position constraints to get arm configurations for exploring this space. I also look at a simplified setup to see how feasible grasping was using the object node attributes. Using the mesh representation of the object didn't really work out so well. There's significant aliasing of the centroid of the object. So kind of wrapping up, adding in the relational edges was pretty straightforward. The careful thought will be needed to appropriately infer the edges in real time. And estimating grasp for unknown objects requires a much finer resolution mesh construction method than what we're using for these large-scale environments. We've used teaser in the past to register known objects to the estimated mesh, but it's unclear if that would work for the smaller objects like the mustard bottle. Thanks.